I'm here today to discuss and talk about a new tool I've been working on for a very long time. We're going to talk about the lock first, and then we'll get into how the tool works and some of the features of the tool. The lock I have been working on is the Sargent & Greenleaf 6870 for the US market, and the 6880, which is the equivalent in the European market. It uses a double-sided type key that can be put in either direction. This happens to be a 9-lever lock. The unique thing about this lock is that when it first came out back in the early 90s, I had developed a pin and cam that I sold for a number of years. And the reason we were able to make that lock work with a standard pin and cam much easier is because when they assembled the levers, lever positions 1, 3, 5, 7, and 9 all went one direction, and 2, 4, 6, and 8 went the opposite direction. So we were able to put strength into the bit of the key that allowed us to use a pin and cam method where the tool was very strong. After a number of years of production, they realized that if they were to simply randomize the spacing of the lock and not necessarily do all the odds going one direction and the evens going the other way, it would render the standard pin and cam design useless. After they did that, it has always been a problem to come up with a tool that has strength to it. Because the keyway is quite small, there are not a lot of tools that you can get in there at once. Therefore, it eliminates the strength of some of the style of tools we'd like to be able to put in. With this in mind, I've been trying to create a way that I could have a pin and cam design tool that would work with any spacing that your particular lock is set up on. Mechanically, there's nothing stopping from all 9 levers going the same direction, or 8 one way, 1 the other, and it doesn't matter which way they go. So you could have 8 going one way and 1 the other, and you could actually load it opposite, where 8 would go the opposite way and 1 the other. So it's totally a universal lock, how it can get loaded internally. And the trick was to make a tool that is strong and efficient on how it works. We'll discuss a few things about how we go about using the tool first, and we'll get into the specifics of the tool itself. The first thing we need to do when working on this particular lock is to determine the spacing of the lock and how your particular lock was loaded. So with the kit, I supply a extended length key, and all we simply do is take a magic marker, Sharpie, color the edge of the key on this side and on the opposite side. And by simply putting in the key in, turning it a couple of times, you instantly know how the lock was loaded on the direction of the spacing of the levers. You can easily do this with a scope, but it's not necessary. With this key, you can actually get all the information you need by simply putting in the key. It allows you to determine the exact way the lock was loaded in 30 seconds. It's a very good way to do it. A scope works fantastic as well, but it's not even necessary to have a scope if you're using this tool. The most important thing that we need to know on how my tool works is we're mostly interested what position the number 9 lever is going. The number 9 lever is the one that would be closest to us, 1 being the deepest most lever, and number 9 would be closest to the front of the lock case, towards the outside of the safe. The reason we do that is we have to be able to put in the tool a certain way every time to enable us to pick the lock. I'll get into more of that later, but we're going to talk about some of the things that we do until we get up to that point. After we determine the spacing of the lock, we simply record that. I give you a little chart you can refer to, but you're essentially determining which way the levers are going. The next step is, because of the design of my tool and why it is so very strong, and most of you are familiar with the tools I create. I don't just manufacture tools to sell them. I manufacture tools to use them myself. And unless they meet my standards, I will not sell a tool unless it works perfectly. And I've been delaying this, making a few improvements, and the final product is just absolutely tremendous. We'll talk about one thing that we do, and I provide tools to accomplish this. Because of the design of my tool, it is necessary to drill a very small hole out the back of the lock. You can see here, I happen to have a AMSAC relocker plate mounted to the back of this lock, and you'll notice how there's a tiny little hole in the back of this. This lock I have pre-prepared ahead of time, but I supply you 2 jigs that allow you to cleanly and efficiently and accurately drill a hole in the back of the lock. And this does not hurt the lock in any way. There is no need to replace the lock after the fact. I supply 2 jigs. First off, I should mention that the longest key that S&G makes in a detachable version ends up being about an 8-inch distance of mounting in the safe. So that is what my tool operates. It's for an 8-inch maximum lock to outside door thickness. So I provide 2 jigs. I provide one that uses a 6-inch bit and one that works for an oversized door that utilizes a 12-inch bit. We just use the shorter one in whichever case the thickness of the door is. So how this works is I just provide a little handle that clamps onto the end of the tool. You simply just put this inside the lock. You'll notice that the tip is cut in a fork. And the reason for that is because the drive cam is actually a shape inside. It is not a round hole. So we simply put the tool down into the base of the keyway. I turn it until it stops. At this point, the drill bit accurately goes down in. You simply, with very light pressure pushing in, you drill in. It just cuts away the very inner section of the drive cam very slightly, and then goes out through the back of the lock. And in this case, there's a relock plate on the back, which is very easy to drill as well. The actual thickness of the lock case where we're drilling is probably only about 30 or 40 thousandths thick, a millimeter thick. So it's a very light die casting that we're drilling. And if there's a relock plate on the back, that's not a problem either. We can drill right through that very easily. So I provide you 2 jigs that allow you to operate any thickness door that this lock would be mounted on. So that's a 1 minute long process to actually prepare the lock to put a hole in the back of the lock. And rather than just drilling it freehand, I've gone to the extra work of providing an exact jig that holds the drill bit exactly inside the lock and makes a very simple way to prepare the lock. After we've done that, we now have the lock ready to begin picking. We'll talk about first, I supply a pin tray. I've removed the screws that hold on the cover here. This is our pin tray. Here are all the pins inside. You'll notice that even though there are 5 depths on this key, there are only 4 depths of pins. The tool is cut for a number 5 depth, and there's no need to use a number 5 pin. We'll just talk about that later. So that's your pin tray. In addition to that, we use what we call a pin grabber that allows me to simply pick up the pins and inject them into the tool or back into the pin tray. Let's talk about the tool itself now. Here it is. This is extremely proud of it. Again, the manufacturing and the quality of materials on this is just tremendous on how I was able to manufacture this. Let's talk about the tip of the tool first. You'll notice that on one side there are 9 slots, on the other side there are 8 slots. Within those slots are holes that go down through them. This is a very high grade, special grade of stainless steel that we've come up with, and it has proven to be extremely strong. I've probably done close to 75 openings with this particular tool, and it has not deflected or distorted one bit. There's no fear of breaking the tool. Now, obviously, if you drop it or are abusive with it, yes, you can break it. But in using it as a pin and cam tool, it's extremely strong. You will be amazed at how I was able to come up with this. There's a few features in here that allowed me to do it that I won't get into here. But basically, we're able to put in 9 pins on one side and 8 on the other. And then this is all dictated by your particular lock that you're dealing with as to how we load it. After going through using the marking key, we have determined what our spacing is. And essentially what we'll do is we'll load all number 4 pins in the proper positions. The 4s would be the shortest pin that I provide. And if you don't put a pin in this at all, this is cut for a number 5 height already. You'll notice as I move the tube down, when the tube is in the number 1 position, which would take care of the deepmost lever, you notice how the tube sticks out slightly out of the end of the tool, in which case when it's inserted in the lock, it of course will come out through the back of the lock very slightly as well. You can sort of see the projection of it there out past the relock plate. So it does stick through the back of the lock ever so slightly. Let's talk about the important part of the tool and how it works. It's all detented. You notice on this side of the what I call the spacing shaft, there are 9 positions marked laser engraved. This is all hardened. This is not simply anodized aluminum. This is hardened aluminum, so it wears. It's designed for long-term wear as well. So you'll notice on this side there's 9 spaces. On the other side there are 8. And there is a flat on the tool here that is basically our home position. So one of the neat things I have done, while the tool is capable, we're always going to put the tool in facing the 9th lever, depending upon which way it is inside the lock. In this particular lock, if the number 9 lever was being pushed up this way, we would always put the tool in with the flat facing towards the bolt. So that number 9 position is always being addressed with the number 9 side of the tool. Had the lever been facing downward the opposite way, we would simply put the tool in the other way every time. So it's always going against the flat towards the number 9 lever. We needed a way to be able to routinely install the tool every time. So one of the neat things that I have done, so you'll notice that I have 9 detent positions here that it clicks right into, 9 possible positions. When I flip it over here, it will only click into 8 positions. You'll notice when you come all the way out, there is not a detent there. It doesn't click in. So that does pull out to a 9th position, but there's no detent. So one of the neat things that I have done is, even though it is not a necessary process to use, I have made this lock capable of spacing it immediately to your particular lock. And let me show you how I've done that. And it's a very simple way and a very efficient way. If you're not in tune mentally with how this lock works internally, you can take away the guesswork as to whether there is a lever in that position or not. So you'll notice that this pulls out to a stop here. It only goes 1 to 9 in this position. What I've done, and what I'm really proud of the way I've designed this is, you simply go to this Allen screw here, you turn it about 3.5 turns out, anywhere in that area there, and then once you get it out far enough, this tool, the spacing shaft, will now pull out to a position that it couldn't get to before. I think you can sort of see that. These are the detent spacing holes. You notice there's some on each side. And basically what happens is that we're able to, I supply you what I will call as hole filler pins. And what you do is you just drop a pin, an exact size pin that I provide. They're all the same. You put in a pin that basically blanks off that detent spacing. So therefore, if we're dealing with the side 1 through 9, and we know happens to be on the side that's equivalent and has the number 9 lever, we may find that, let's say, just for this case, that levers 4, 6, and 8 are on the opposite side. So all we would do is drop in a pin in position 4, 6, and 8. And therefore, once we push this back in, and we just turn this down, you don't have to tighten it hard, it just comes down to a stop. Once we do that, this will not jump into the 4, 6, and 8 on this side. So you can actually load the tool for the spacing of your lock. Now, it's not necessary to do this. The tool will still work fine if you want to count or watch the actual markings on the tool to determine your spacing. But it's basically allows you to set the tool to your lock no matter what the spacing of the tool is. Once you get the lock prepared with a hole in the back and the tool set the way you want, if you want to load it for the exact spacing, you now install number 4 pins on all 9 positions. All we're doing is simply going in, putting the tool into the lock, turning it, and you only have to turn it with light finger tension. You're not forcing the tool in any way, and all we're doing is, this requires no picking ability whatsoever. I'll try to get in a position here. Now, I don't have the pins loaded in this, but essentially, if this is free to push in, and the smoothness of this is just amazing how well this works. If it's free, leave it alone. So after we check that, I usually start at the number 1, I check that, I come back, check that, come back. And if the button is hard to push in, you know the pin is the wrong size. So you take out the tool, you take out the number 4 pin, you now load it with a number 3. And you can make multiple changes at one time. Very often you'll maybe find 3, 4, 5 positions that are wrong when on your feeling of it. If you remember which ones it is, you can just pull it out and change all of them at one time. The neat thing about one of the factors and how I designed this as well, and a lot of these smaller factors make a huge difference, is that if I push the tool, the plunger, when I'm not underneath a pin, let's say I'm in a blank spot, that's not a problem. With many other people's pin and cams, if you press the pin in the wrong position, the ball comes out and doesn't set back into the tube. Doesn't matter on this tool. I've designed this exactly. So if I press the tool with the plunger in at a point where there is no pin, the ball does not get trapped up into a blank space. It always returns to the tube. So you'll get a full set of instructions with this, of video instructions and written instructions that I go into more detail. The tool is absolutely amazing. Once you've prepped the tool with the hole in the back of the lock, I have opened locks generally between 7 and 20 minutes. 6 or 7 minutes was the lowest I've ever done one, and almost all the time I'm completing the process in 20 minutes. Once you open the lock with the tool, you simply press the button on the back, take a new set of keys, turn it out, and you're done. There's no need to replace the lock. The fact that we have drilled this tiny little hole in the back of the lock has not damaged the lock in any way. And this tool is just absolutely amazing. As I say, most of you are familiar with the quality of stuff I manufacture. This by far is probably the most elaborate and perfect working tool I have ever produced. Feel free to email me at lockdefeattechnology@comcast.net for purchasing, pricing, and instructions. Thank you.